My name is Gareth, and this is my electromagnetic launcher. I built an electromagnet using copper wire, wound 600 times around an acrylic tube, and connected it to an electrical power source. Here, I've used an acrylic tube so we can see what happens inside, and also I can use LED infrared sensors to track the speed of my projectiles. I connected the two wire ends to an electrical power source. I'm using an adjustable voltage lab bench power supply and a capacitor so I get a consistent voltage output each time I fire the launcher. I connected a voltmeter to monitor the voltage stored in the capacitor and to show me that the capacitor has fully discharged after it's been fired. I programmed an Arduino for these LED sensors to collect an elapsed time and then calculate the speed of each projectile. These blue ones are called transmitters and the clear ones are receivers. They work as a pair to create an infrared beam. When the beam is broken by the passing projectile, the information is collected and the start and stop time will give us an elapsed time, which can then calculate the speed from because we know the distance. Here I attached a ruler so I know the distance between the start and stop sensors. Let me show you how this works. Flick the switch to charge the capacitor. Load the projectile. Flick the switch to arm the launcher. Press the yellow button to fire. Now we can see the elapsed time and the projectile speed. I built these Lego walls and covers so my projectiles won't ricochet and fly away. The long side walls prevent any lights or shadows from affecting the LED sensors. I've also included a weighing scale to measure the mass of each projectile so I can calculate the efficiency. Here are some of the projectiles that I have made. This is from a tent stake, this is from a coat hanger, and this is a spring from a pen. These materials have to be ferromagnetic, meaning a magnet will be attracted to them. I tested the different projectiles 10 times each and then worked out the average speed and efficiency. I also tested the projectiles within the addition of neodymium magnets on two sides of the coil. I found that it did speed up some materials. What was interesting is what I call the spring booster effect. When I added a spring in front of the projectile, the speed increased, and when I inserted the projectile into the spring, it also increased the speed. By adding the neodymium magnets and using the spring, I think these affected the electromagnetic flux and gave me better speed and efficiency in some projectiles. I decided to get data for speed and efficiency because you might want to use different materials for different purposes. For example, on an aircraft carrier catapult system, you will want the armature connected to the shuttle to move as fast as possible, whereas for a train or a rocket, you will need a material that uses the smallest amount of energy to give you the furthest propulsion. Thank you very much for listening.